Let's have a look at a velocity time graph. We're going to consider a very simple case to begin with, where we have a constant velocity for some time that we're travelling. You're probably familiar with distance is speed times time from GCSE, or some of you may have seen it as distance, speed, time, using the formula triangles. Exactly the same will be true of velocity, except we will now talk about velocity and displacement, because remember we can now go into the negative region of the graph. So we'll have that velocity times multiplied by time is equal to displacement. Somewhat confusingly, we use the letter S for displacement rather than for speed, so we will always be working in vector form here. Velocity multiplied by time gives us displacement. Okay, remembering distance is the scalar version of displacement. Displacement is distance, but it can be negative. Okay, so what happens if we don't have a constant velocity? Well, previously we had, for our constant velocity case, displacement, is velocity times time. Thinking about that, that's actually given us the area of this rectangle. So now we can look at this case where we start at some velocity v for some time t. Area will be represented by, displacement will be represented by the area underneath this graph. So the displacement is this area here. Velocity, time, we've got a triangle, so our displacement will be a half vt. Okay, so remember, displacement is the area between your graph and the time axis. In this case, as we have a triangle, a half vt. Okay, so now let's see how we can extend this idea a bit further. Imagine that we have some more complex scenario, say a train accelerates up to some speed, let's call it 30 meters per second, travels at a constant speed, and then decelerates. Let's also add some times to this. So we'll say that it accelerates up to a velocity of 30 meters per second in 20 seconds, travels at a constant velocity for a further 100 seconds. So remember, we need to keep a running total down here, and then comes to rest in, well, if we look at this, it appears to be a slightly sharper gradient, so it's decelerated in less time. Let's call that 130. So it took 10 seconds to decelerate. I want to find the area underneath this graph, so the area between the graph and the x-axis and the time axis. So what kind of shape do I have here? I could split it into two triangles and a rectangle, but there's no need to do that. I have a trapezium here, so I can do the area of a trapezium, which, if we recall, is a half of a plus b, a being and b being the two parallel sides. So if we look at that, we've actually taken the average of these two lengths multiplied by the height. In this case, that means that we have the average between when we were travelling at 30 and the overall time. So we were travelling at 30 for 100 seconds and a total time of 130. So we're looking at the average of those two lengths multiplied by the height. That's going to give us 65 multiplied by 30, which is 1950 meters. Assuming that this is in seconds, that's in meters per second. 65 times 30 would give us the distance covered by this train. Okay? One final thing that we may want to calculate, so we've seen that area is the displacement. Finally, acceleration in this first section here, so we'll call this A1 for the first section. Acceleration is the change in velocity per unit time. So in this case here, we had a change in velocity of 30 and a change in time of 20. That is change in y over change in x. So acceleration is the gradient. In this second section here, let's call it A2. We have 0 change in speed for 100 seconds, so we have no acceleration. Constant velocity is a horizontal line on a velocity time graph. And then finally we have this third section here, let's call it A3. We have an acceleration of minus 30, we've lost 30 meters per second. Remember, acceleration is a vector, it can be negative, we need to describe a direction. And that took 10 seconds. So we have a deceleration of minus 3 meters per second squared. Sorry, I forgot my per second squared on that one. Okay, so there we have it. Velocity time graphs. We can sketch them, given some information. We can then calculate areas, which will give us displacement. And we can calculate accelerations, which are gradients.